points in, so it's like nice. And basically what we're going to do today is we're going to turn around the process we did yesterday. Yesterday we graphed quadratics from the three forms. What were the three forms we did? Standard, vertex form, and what else? Factory form. Very good. And you did the little foldable and all this stuff. Well, today we're going to turn that process around. I'm going to give you some points, or I may give you a graph, and you have to write the equation. So we're going to turn the process around. Rather than giving you the equation and you graphing it, I'm going to give you a graph of points, and you have to write the equation in the designated form. So, for example, this is what it would look like. Write an equation in vertex form of the parabola containing the points. Now, V, what do you think this V stands for in front of this particular point? Vertex. So that's the vertex, and it also goes to the point 2, 8. Write an equation in vertex form. So the first thing I'm going to do is just write down the generic vertex form, which is, let's see, x minus h squared plus k, right? Well, what can I do with the vertex with the points 3 and 5? Where can I put those in my equation? H and k, yeah. So just from what I'm given, I've got y equals a, so I write x, let's see, plus 3, right? And then plus 5. Nope, this would be minus 3. Because I want it to be, yes, the opposite of this and exactly that. That's easy. Now I have 3 variables left. I have a y, an a, and an x. And I need to figure out what all 3 of those are. Really, the a. So where else on the screen do I have an x and a y that I have to plug in? Right here. I know that this point is going to be part of the solution because it's on the line of the parabola. So I could plug in 2 for my x and y, 8 for my y, and then solve and see what a is going to be. So that's what I'm going to do. So 8 equals a times 2 minus 3 plus 5. 8 equals a times -1. Thank you very much. So -1 squared is just going to be 1 times a. So this is going to be a over here. I bring my 5 to the other side and subtract it. Looks like a is 8. So my final equation and my final answer, written in standard form, vertex form for those 2 points would be y equals a, which is 3, x minus 3, plus 5. Large values.
Should be x minus 3 squared.
Yes. So basically, we're just going to think about the form, which is why I had you get your booklets out to think about what the form looks like, what the goal is, and then what do each of our numbers do, each of our A, H's, and K's. Right? What if I give you a graph instead? Same thing. This time, it's still vertex form, isn't it? Still vertex form. So vertex form is still going to be y equals a x minus h squared plus k. Well, it didn't list the vertex, but it shows me the vertex. So let's stick those in for h and k, remembering what looks to be opposite, what's the same. So now I've got x minus 1 squared minus 2. Easy. And it gives us, we could use any point on the line, but it kind of gives us one to work with right here, 0.32. So that's an x and a y we can plug in. I know that it should make the equation true. So 2 equals a. What did you say?
Negative.
No, positive 2. Positive 2. Oh, no. Down here, no, it's negative 2 because I'm using that. I'm using this for my vertex. This is as a help. You good?
Yeah.
Alright. So now I've got 3 minus 1 is 2. 2 squared is 4. So I've got 4a minus 2. And 2 across the river equals 4a. So a equals. No, yes, 1. So putting it all together then, it's going to be y equals 1 for my a. Where did I have it in right here? X minus 1 squared minus 2. And I like to go back and make sure everything is as should be, especially the vertex. And that's what it should be. As long as you know your parts, the parabola, and you know the formulas, you're pretty good to go on this type.
Do you have to write the one before, like?
You don't have to. I just did it for emphasis. Yeah, you don't have to write the line. All right. Now, this one gives me a little bit different information. Write the equation in factored form. The factored form of a parabola that contains these 2 points, or 3 points actually. 3 points. Now these points are very particular points. Let's think about it visually. The point 50, that's an x-intercept. And the point 10, both of those. 10 is an x-intercept. These two are x-intercepts. Right? Wait a minute, x-intercepts can be turned into factors. This is a 1, and this is a 5. That's my p and q in the factor form. So I can start writing my equations. Oh, you know, I didn't write the generic equation. It'd be better on your paper, but it's y equals a, parentheses, x minus p, x minus q. Hey, that is a lot of x's and p's. So, I've got then, so far then, I've got y equals a, and I'm going to do x minus 1 and x minus 5. Now I'm down to 3 variables, a y, an a, and an x. But again, I've got this x and this y that I can plug in to figure out what my a is. So in place of y, I'm going to put in a negative 2. A is what I'm looking for. My x is 2. Both places. So let's see. This is going to be 1 times 10. So that's going to be 10a. 1 times 10 is 10 times a.
Would it be negative?
Yeah. Minus, once you're on the front row right there, you just speak right up. But again, so it'd be negative 3a. Right? 1 times negative 3, negative 3a.
We'll divide this up into 3. Good? So to put it back into the equation for my final answer, it's going to be y equals a, which is 2/3, x minus 1, x minus 5. Needed it in factored form, right? Yep, factored form. So got it in factored form. 2/3 times y times y. So these are all 3 factors. Good? Okay, let's try a different type. This one says to write in intercept form. Wait a minute, what is intercept form? Good. So the name for factored form. So don't let that confuse you. Okay? Whenever you see intercept form, you should have on your foldable, make sure you have both of those listed for that type. I'm just talking about depending on the publisher of the book. Those could be the same thing. All right, I'm just going to jump right to it because I know this is my P and this is my Q. So I know that in factored form, so I need an A. This is going to be X minus -1. So plus 1 and X minus 4. And then for emphasis, they showed me that this would be this 3, 2. This x, y, I can use to plug in. So my y is 2, x will be 3. So this is going to be -4a. Like a is -1/2. Oh, that makes sense because it's open and down. Should be a negative. So we'll put her all together. Actually, I think it's going to just block. Yep. Small though. The final answer would be here. Y equals -1/2. Yep, like that. Parentheses x plus 1. Parentheses x minus 1. All right. This one will be the same way. Just notice that these two are x-intercepts. Right? So those will be my P and Q. Did you do that one or do you need me to do it? Okay.
What if they're not those x-intercepts?
Well, let's do one of those. Good question. Let's try this one. Write the equation in standard form of the parabola containing these points. That means they want it in standard form. And none of these points are the x-intercepts. Darn. So what the heck? Well, let's see. Standard form is y equals ax squared plus bx plus c, right? Will any of those points help me fill out my A, B, or C? That's right. Because what's this right here? That's your y-intercept. And which of these is your y-intercept? It's the C. So I know my C is -4. So I know I'm going to have a -4 hanging out here. But this one I'm going to have to do using a system of equations, which is what we did last chapter. I'm going to make 2 columns here. I'm going to work with this point, -1, -3 over here. I'm going to work with 2, 6 over here. So over here, I am going to use this for my x and this is my y. And I already know my c is -4. So this will produce y equals a parentheses, -1 squared, plus b times -1 minus 4, because I already know c is negative. So this will turn into -1 squared and +1. So this will be a b times -1. Oh, I put the right one, didn't I? I don't know why. Why is it 3? So that's a positive a, and that's a minus b. So let's take the 4 across and add it to here, so that was 1, and 1 equals a minus b. Okay? All right. Now let's do the same thing on the other side. This time, though, I'm going to use this x and y. So now I'm going to have 6 equals a times x squared plus b times this x plus c, but I know my c is -4. So this is going to produce 4a, 2b, and I'm going to take that 4 across. So then look what I produced. I produced 2 equations with 2 unknowns. So I'm going to put that together into a system. And both those down. You want to go in and I'll be wanting to eliminate. So how about we multiply this whole thing by 2 so we can get it to be -2b? You all right with y'all? So I'm going to multiply this by a 2 on both sides and bring it down. So that's going to be 2 equals 2a minus 2b. Bring that one down. 10 equals 4a plus 2b. It's a equals 12. A equals 2. There we go. There's my A. I've got my A and I've got my C. Remember, we're looking for a standard form into A, B, and a C. So let's find our B. So plug this in wherever you want, wherever there's two unknowns. Shoot, that's at least one. Let's stick it right there. So 1 equals 2 minus B. Take the B across. Take the 1 across. Looks like B is 1. And then as we found that up top, the C was what, -4? Okay. All right, so let's put that in the form it wanted. Wanted standard form, and now I've got my A, B, and C. So y equals a x squared plus bx. I'm going to just put a 1 for emphasis, minus 4. So there's the equation in standard form. It goes through those 3 points. That's the hardest type to do right there. Not as hard, but you have to know that we come along, yeah. You have to set it up in your, system and all that stuff. Good with that? And I think, yep, that's it.